In today's video, number 2.5, we're going to talk about two different things, molarity and dilutions. So by the end of this video, you should be able to calculate the molarity of a solution and calculate the molarity of a solution after it is diluted. You also will need to definitely make sure you know what molarity is and be able to define that. So there will be lots of definitions in this video. So the first one is the difference between concentrated and dilute. Concentrated solutions have large amounts of solutes dissolved in the solvent, whereas dilute solutions only have a small amount of solutes dissolved in the solvent. So if you look at this example here with the tea, this one I believe is more concentrated. It's darker. You can see there's probably more tea dissolved in the water than with this one. Another good example of that is like Kool-Aid or something like that. If you dissolve a lot of Kool-Aid in water, it's more concentrated, and if you just dissolve a little bit, it is less concentrated. So when we talk about molarity, is basically just a measure of concentration. So concentration is the amount of solute, or stuff that is dissolved, in a solvent, which is usually water. That's concentration. So molarity is a type of concentration, or a way to calculate concentration, where we talk about moles of solute per liter of solution. So moles per liter. There should be some information about it on your reference tables. Make sure you know where to find that. The units for molarity are moles per liter, which is sometimes written moles times liters to the -1. Remember what you do when you have that negative exponent. Or it can just be abbreviated with a capital M. So sometimes when you see that capital M, that's just molarity. The equation to calculate molarity looks like this. So molarity equals moles of solute divided by liters of solution. And one thing we need to remember, because volume can change with temperature, molarity also can change with temperature. So that's something to keep in mind. Occasionally that'll become important when you're working through some problems. So here's some quick examples of how to calculate molarity. We have 3.0 moles of sodium chloride dissolved in 6.0 liters of water. So what's the molarity of that solution? Remember, molarity is moles per liter. So we just do 3 moles divided by 6 liters, which gives us 0.50 moles per liter, or molarity. And we see here in each of these we have 2 significant figures. So our answer needs to have 2 significant figures, even though it's not written in the work. But the answer needs to have 2 significant figures. Try this one. If 29 grams of sodium chloride are dissolved in 1 liter of water, what's the molarity? Remember, molarity is moles per liter, but here we have grams. So the first thing we need to do is convert grams to moles. So 29 grams divided by 58 grams, which is the number of grams in 1 mole of sodium chloride. So that came straight from the periodic table. The amount of moles for sodium and chlorine, added them together. So then 29 divided by 58 is 0.5. So we have 0.5 moles of sodium chloride. 29 grams is equal to 0.5 moles. And then when we dissolve that in 1 liter of water, the molarity of our salt solution is 0.50. It's 0.5 divided by 1 is just 0.5. And again, we have 2 significant figures, because back up here in my problem, I've got 2 significant figures. Let's try another few examples. These are examples that we'll probably need a calculator for. Because again, we have grams. So we have 100 grams of potassium fluoride dissolved in 300 milliliters of water. What's the molarity? So remember, the first thing we need to do is convert grams to moles. So pull out your periodic table, and we see that in 1 mole of potassium fluoride, there's 58.1 grams. So that's grams per mole. 100 grams divided by 58.1 grams equals 1.72 moles. So these 100 grams of sodium fluoride equal 1.72 moles. Now we can actually do the molarity, which is the main problem. We have that 1.72 moles divided by 0.300 liters. Because this is milliliters, we had to convert it to liters, which is 0.3. So 1.72 divided by 0.3 is equal to 5.7. So our molarity of this solution is 5.70. And again, 3 significant figures, because in each of these there are 3 significant figures. That decimal point makes it important, right? 3 significant figures. Now this example says calculate the volume needed to create a 2 molar solution with 3.5 moles of lithium oxide, Li2O. So this time we need to figure out the volume. We know the molarity, we know the moles. So we've got to work our equation around a little bit. We get 2.0 moles per liter, that's my molarity, equals 3.5 moles divided by X. That's my volume, my liters that I don't know. Remember, molarity is moles divided by liters, and liters is what I don't know. It's what I need to calculate, right? Calculate the volume. So when I work this problem through, do a little algebra magic, I get that X is equal to 1.8 liters. So in order to create this 2.0 molar solution with 3.5 moles of lithium oxide, I need 1.8 liters of water. That makes it work out correctly. Now I want you to try this problem. It says if you have 3.12 grams of hydrochloric acid and 250 milliliters of water, what's the molarity of the acid? So I want you to work this through. Remember, got to change grams to moles. Pause the video and work this through. Find the molarity of that hydrochloric acid. Then answer this question. If 250 mils of water is added again, how does the molarity change? Does it go up or go down? Increase or decrease? So think about that for a minute. Pause the video. See if you can work that through.